Okay, good morning, everybody. I hope you're well. And we're going to go to work today on hypothesis testing. Okay, and yesterday we went through the setup for hypothesis testing. Um, things like what's a hypothesis? What kind of hypotheses do you have? Things like that, null or alternate. So you guys are going to see some of that today in the details, right? Devil's in the details. Okay, so we went through the process yesterday. And hypothesis testing, let's start off with the first example. And so it's always kind of fun to think about what kind of things people care about. We're going to do hypothesis testing about a mean. So we can say, maybe we can start with something like that, the average age of college students. We can say Snodgrass claims, and that's Professor Snodgrass, claims the mean age of college students is 25 years of age. It's simply saying 25 years, okay? And this is Professor Snodgrass. A sample reveals, I should say a sample of size 100. Well, let's change that number. 200. Reveals a mean of, let's say, 23.6 with a standard deviation of maybe 2.8 years. Okay, so these are both years, so we know that. All right. Use the 5% level of significance to test this claim. Okay, I'll give you guys a few seconds here to write this example down for yourselves. Okay, so here's going to be your first hypothesis testing question. It's going to be about a mean. So we'll give you guys a few seconds there, kind of write that down. All right, let's go through the details. Now, the first kind of question that people ask me for hypothesis testing is, they'll say, believe it or not, they'll say things like, Mr. Judge, how do I know this is a hypothesis testing question? I don't know. And I'll say, well, read it. And you see Professor Snodgrass, here's a phrase, claim, right? Oh, a claim. What's a claim? Anybody know what a claim was again? Claim is a hypothesis, ladies and gentlemen. And you read all the information, and then they start to say, use the 5% level of significance to test this claim. Oh, okay. That means this is a hypothesis testing question. If it were estimation, they would say things like estimate. So it's hypothesis testing, and you say, okay, so I guess that's what I'm going to have to do. All right, now that you know it's a hypothesis testing kind of question, what's the parameter? What parameter are they testing here? And you read this again, and you say, oh, Professor Snodgrass claims that what? The mean? Oh, that's my what? That's the parameter. And it's saying that the mean age of college students is 25. So here's what I'm going to say to you guys. Yesterday, we translated those statements. Write it down. Mu is 25. And also, I'm going to say this. Label it as the claim. That's an extremely important step. Reading what the hypothesis is saying, the symbolism, the inequality or the equality that they give you, you want to write down. But probably just as important is to say that, remember, that's the claim. This is what Snodgrass is claiming. Snodgrass is saying that the mean age of college students is 25 years old. That's what he or she is saying. That's the first thing you do. Now, if you go through our procedure from yesterday and you say, oh, what do I do? What's the first thing you guys do? You set up the hypothesis. That's the first thing. You set that thing up. So here's our setup. You have H naught, you have H1. Now, tell me, and let's see if you guys remember from yesterday, where does that claim belong? Is that a null hypothesis or is that an alternate hypothesis? Is that a null or is that an alternate? Okay, anybody know? Is that a null or an alternate? This is where you start the process. A condition of equality makes this statement a null hypothesis. So mu is going to belong in that position. This is where you put that, and also, if you like, label it the claim. So you're putting that in the right spot because this is a null hypothesis. Now, let's ask you this question here. What's the opposite of this statement? Right? What's the opposite of a null hypothesis? What do I write down? Right? What's the opposite of equal to 25? Does anybody happen to know? Not equal to 25. Those are logical opposites. Either you are 25 or you are not 25. Okay? These statements always have to be opposites. All right, we're going to see that. Now, let's ask you guys a question here. Right? This is called the hypothesis setup. Once you set up the question, they're going to want to know now, what's your decision rule? So if you go back here and look at what we did, we set up the hypothesis. We are now going to create our decision rule. That's what we're doing next. And you say to me, okay, well, let's see. We'll create a decision rule. Yeah. Here's my point. We now have to draw a bell. Here's a picture of your bell. This is going to be how we create the decision rule. Now, if you guys remember from yesterday, we talked about this. I mentioned this. What do you look at? Is this a one-tail test? Is this a two-tail test? How do you determine whether this is a one-tail or two-tail test? You have to look at something. What do you guys look at? You always look at the alternate hypothesis. And when you see not equal, that's two tails. Always, always, always. So you're going to have two tails here. Now, just like we wrote down yesterday, the middle portion is going to be the do not reject the null region, that middle portion. The tails, this is where we reject the null. So you're going to reject this null. Okay, we're almost done with the decision rule. So this is how we're starting to set up this decision rule. And I'm going to say this to you guys. They're telling you here to use, I'm going to color this, the 5% level of significance to test this claim. This is 5%. What that means here is simply alpha here is 5%. And if alpha is 5%, 2.5% is in each tail. We just need now the critical values. There's two. Now, the reason you have to know about the level of significance is when you find the critical values here, we're looking at the Z table. So remember that 2.5% now means this portion is 47.5%. This portion by symmetry is 47.5%. You have to find a critical value associated with this picture. This is why a picture is worth 1,000 words. This is why I ask you guys, whenever you have a test, you don't just upload answers, you upload the work. You guys understand? You upload your work, because this is an online setting and a lot of funny things can happen. This is why I require you to send your work, ladies and gentlemen, so I can compare to see your work versus other people's work. And if it's the same thing, then we know something's up. So, you know, some people submit things without the work, and I'm not going to accept it. You got to show me that work. Where's your work, right? So let you guys know, you're going to have to draw some of these pictures to kind of deduce this, right? So we need a picture. We need critical values. So if you can go to the Z table. Now I got to find my Z table file. Go, was it in files somewhere? Oh, we're in 227. Yeah, let's go look at that. If you guys remember. Here we go. Tables. I don't know if that was it. No. I mean, it is it, but oh, I can write. Interesting. Write on a PDF. Here's a Z table. Okay. It just doesn't let me scroll up and down. Done. All right, I guess I have to go to the Word version. Here we go. So this is why I said to you guys, we're going to be working with tables for quite some time. You're going to have to look for 47.5%. Remember that? Right, 47.5%. And it's in a box. This is weird. If you guys can see it, it's right in here. Well, I don't even think Word likes what we're doing either. Here you go, Word. You guys can see that. There's where that 47.5% is. It's in a box. They knew you were looking for it. What's the Z value there? Can you guys read it now? It's in the 1.9 row, and it's in the 0.06 column. Oh, it's 1.96. That wasn't good. $47.5, ladies and gentlemen. So here's what you're going to use as critical values. 1.96 and minus 1.96. Those are your critical values. Okay, good. So, I'm going to change that color on you guys. This is the important information you guys need. This is called my decision rule. And now we're good to go to try to go to the next step. So here's your decision rule. This is what you guys do. And you say, okay, well, what's the next step? Well, the next step is, well, we're already here. The next step will be go out and take a sample. Right? We did this. Now we have to go out. We have to take a sample. And you say, okay, going to take my sample, but you're not really going to take a sample. They give you sample information. What do they say? A sample of size 200, that's N, reveals you have a mean of 23.6. Well, that's a sample mean. And you have a standard deviation. Well, that's your sample standard deviation, right? So in other words, notice you don't really go out and take a sample. They give you the sample information here. So I'm going to say sample here. I'm going to have to write this down. My size was 200. The sample mean was 23.6. The sample standard deviation they gave us was 2.8. All right. So that's taking a sample. Okay, here's my sample. Oops, don't need that. So after we take that sample, what did we say yesterday? We did this now. Oh, what do? We're going to compute a test statistic. All right, based on your sample, we're going to use a formula. All right, I need a test statistic formula. Okay, let's go back and test statistic formula. Here's your test statistic formula, ladies and gentlemen. TS is X bar minus mu over S divided by the square root of N. This is the test statistic formula that you guys use. This is what you use to determine where your test statistic value lives in this decision rule. And all you now got to do is plug things in. Okay, that's all you have to do. But you got to know what you're looking at. You go, what do you mean? Yeah. The sample mean is right up in here, right? This is 23.6. The sample standard deviation is 2.8. The sample size is 200. So I want to say to you guys, you have this. They just gave it to you. This is the sample mean right in here. Here's your sample standard deviation right there. Here's the sample size right here. So you have those values that you're going to plug in your calculator. You just have to know, what is mu? You go, yeah, what is mu? Well, mu is way up in here. Mu is 25, ladies and gentlemen. So you're going to plug in that 25 here. And as you guys know, what I do in my calculator or on my paper is I want to be very clear. 23.6 minus 25 divided by 2.8 over the square root of 200. This is the test statistic value. Now, we're going to have to use the TI here. And here you go. So I'm going to put in the numerator, I put a parentheses, ladies and gentlemen. And then 23.6, that first number, minus 25. I'm going to close this parentheses. I have to do this because I'm telling the calculator, hey, calculator, I have some work to do in the numerator. And then I'm going to divide. And I'm going to open my parentheses again because I have some work to do in the denominator. And you say, what's that work? I got 2.8 now divided by the square root of 200. And I'm going to move out now of that region under the radical. I press that arrow and then I close this parentheses. And ladies and gentlemen, just to illustrate the great detail here, go back to the iPad just to illustrate this. What we're saying to the calculator is, hey, calculator, this is a numerator in parentheses. Down here, I have the denominator in parentheses. So this is why I have to put parentheses around both of them. In other words, I'm telling the calculator, parentheses, parentheses. And then don't forget the meaning of what you see here. This is to divide. So all of that is what we're doing in our TI by using the parentheses the way I described here for you guys. So the first set is the numerator, then division sign right in here, and then the last set. And then now we hit enter. And ladies and gentlemen, here's what we get. We get a test statistic value. Now, the most common question at this point people ask is, Mr. Judge, where do I round this answer to? Where do I go to? I go to whatever the critical value is. The critical value is to the nearest hundredths. So I'm going to round this test statistic value also to the nearest hundredths. That's minus 7.07. So you want to round to the critical value, place value. And the critical value is in the hundredths position. So let's go back to the TI, or let's say, the iPad, and let's see that. Negative 7.07, you go, oh, do I round to the same place value over here for my critical value? Yes. And then you say, why? Because you have to see where the value of negative 7.07 lives in your decision rule. Where does it live? Well, this is 0, and positive numbers are to the right, negative numbers are to the left. So, ladies and gentlemen, the test statistic value is actually past the critical value. It's like way out here. In fact, maybe I should say it's way out over here. This is where negative 7.07 would be if we extended, right? And let's try to extend this here just to show you. So your test statistic value is negative 7.07. And here's what I have to say. What region does this number of negative 7.07 live in? This is what you guys want to know. What does it live? Where does it live? Tell me the neighborhood. Tell me the region it lives in. Anybody know what region this is in? It's in the reject the null region. So let's be careful here. I'm going to write down that phrase. I'm going to write down the phrase reject the null, and then I'm going to go to the format here. You see, yes, we took a sample. Not really. We just wrote down the sample information they gave us. Yes, we computed the test statistic using the formula. We got that negative 7.07 value. And what does it say here? We now have to draw our conclusion. Determine where the test statistic lives in your decision rule. You're going to draw a conclusion now. So let's try to draw a conclusion. What you're looking at here is not the conclusion. This is not the conclusion. Let's write that down. And you say, well, what is the conclusion? Well, it says to reject the null. So does anybody want to tell me here? Which statement here is the null? Do you guys know where the null is? Here's where the null is, ladies and gentlemen. It's right here. And when you reject something, you're saying, you're throwing it out. You're rejecting. It's going out. And what you happen to reject is this important statement right here. You just rejected. You just threw out the claim. Now, this is what you guys say. This is what you have to say to get credit for this particular process. You have to say it this way. You can't make this up. When you rejected the null, you rejected the claim. And the claim is based on, the rejection is based on a sample. So here's my conclusion. Here's what you say. The sample does not support the claim. This is your conclusion. Now we're going to have all kinds of discussion about this conclusion. People are going to go, what? The sample, ladies and gentlemen, does not support the claim. You see, the test statistic is based on a sample. Based on the value, it says reject the null hypothesis. The null hypothesis just happened to be the claim. This is why you guys want to write that thing down. So when you reject that claim, what you say is the sample does not support the claim. It actually rejects it. What this sample really suggests, ladies and gentlemen, the sample suggests is that the mean age is not 25. That's what this sample is suggesting. But what you write as a conclusion is that the sample does not support the claim because you are testing the claim. Right? It's a hypothesis test. It's a claim test. Remember, claim is the same as a what? Hypothesis. And in this case, it was the hypothesis that mean is 25. So the sample does not support that claim. It actually really supports the alternate hypothesis, which is that the mean age is actually not 25. So ladies and gentlemen, this is your first formal hypothesis testing question, and it's called the traditional method. So I'm showing you here this traditional method this morning. All right. Okay. There it is, the traditional method. All right. So we're going to look at some other examples because, we have three types of tests. At least I want to get to the three types of examples here. And we're going to start another hypothesis test about a mean. This time we're going to say something like this. We're going to say, okay, Professor Snodgrass claims the mean amount of coffee students drink the night before a final is at least 3 cups. Now, sometimes you have to define a cup, right? We're going to say 8 ounces. So he's really saying, 24 ounces of coffee. Ooh, that's a lot. Okay. A sample of 50 college students report a mean of, let's just say, 3.3 cups with a standard deviation of 0.6 cups. Use the 90%, I'm sorry, I made a mistake. Use the 10% level of significance to test this claim. Okay, this is another hypothesis testing question. We're going to test the claim here. And you say, how do I know I'm going to test the claim? What does it say? Test this claim. Oh, that's a hypothesis testing question. Now read this. What is the claim? What is Snodgrass saying? Snodgrass is saying that the mean amount of coffee students drink the night before a final is at least 3 cups. So I know the parameter for mean is mu. So I'm going to write this thing down. I got to say mu versus 3 cups. I need to know the meaning of this phrase right here, of at least. So the mean is at least 3. So ladies and gentlemen, at least 3 means 3 or more. So that's greater than or equal to 3. Okay, 3 or more. This is the claim. And so what you'll do here, that first step is you're going to set up your hypothesis. And you say, okay, what do I do? H0, H1. You have to know, where do I put this claim? Is it a null or is it an alternate? Again, it happens to be a null because of the condition of equality, and that's where you put it down. I even put the word here, claim, next to it. Okay, because of the fact that this is going to remind me what I'm testing. Now, what I said earlier is the logical opposite of at least 3 is going to be, remember, greater than or equal, it's less than. These have to be logical opposites. This is setting up the hypothesis. And so if you said, okay, what happens next? What happens next is you create your decision rule. And your decision rule, ladies and gentlemen, is what we're going to have to write down. Now, I'm going to remind you guys, you always look at the alternate hypothesis. Now, yesterday we described, you're looking at this portion here. We need to know, what does that mean? Well, that arrow's pointing to the left. That means we really have a left tail test. So this tells me we have a left tail test. More importantly, it's a one tail. So when I start to set up the regions, the non-shaded region is do not reject the null. The shaded regions is to reject the null. Alpha, ladies and gentlemen, is our level of significance. We have to find out what that is. It says use the 10% level of significance to test this claim, 10%. So that means alpha here is 10%. What that means is 10% of the area is right in here. It's all in the left tail. There's not two tails here. There's only one tail. So put all of that in one tail. Now, that's important because we're going to try to find a critical value. And if you guys remember, this is going to be a z-value here for this. So if 10% is in the tail there, that means this is 40%. So this is why we care about the level of significance. We need to find our critical value. To get the critical value, we're looking for 40%. And you say, okay, 40%, let's get rid of this, let's get rid of this. 40%, by the way, if you guys remember, is 0.4000. That's 40% numerically as a decimal. So we're looking on this table here for 40%, and we're trying to get as close as we can. And you guys know something. I see this. I see 39.97, and then I see 40.15. Okay? That's the closest I get to 40%. You know what I'm going to do? I'm going to use the 39.97 because that's 3 pennies short. The 40.15 is 15 cents over. Even if I took a midway, it doesn't help me. The best answer I get is 39.97. So it looks like it's going to be here. I'm going to erase this one. We can't do midway. It looks like this is going to be in the 1.2 row, 0.08 column. See this? 1.2 row, 0.8 column. 39.97 is the best we can do. That's 1.28. But it's negative because it's to the left of 0. This is your real number line. It's to the left of 0. Positive numbers are to the right over here. To the right of 0. So all the positive numbers are. And then negative numbers are going to be to the left. We got to read where this test statistic lies in relation to our critical value right here. This is what we found. And, where's a redo? They should put a redo. All right, let's see where this lives. I'm gonna paint this as a negative in blue. So it's negative 1.28. Just so you guys know, there's your critical value. So we're gonna need to find the test statistics. So at this point, you're gonna use the formula. Now, this is what I'm gonna say to people when you do these questions. You should write down the formulas that you use. You want to write them down. Every time you use a formula, you write it down. It's like learning how to spell your name. So when you actually do the work on a test, final, wherever, you're not trying to look at a whole list of formulas and figure out which one to use and go eeny, meeny, miny, mo. You know the formula. You write it down. This is how you do things. So write down that formula, and then you say, what comes next? Oh, we got to take the sample. Not really. They're going to give us sample information. Say, what sample information they're going to give me? Well, let's see. It says what? It says I guess we did it in red earlier, right? A sample of 50 college students. Oh, that's N. Report a mean of 3.3. Oh, that's X bar. With a standard deviation of 0.6. Well, that's S. So you're going to have to write this down. N is 50. 3.3.6. So the sample information is given to you in the question. It's given to you. Okay, it's all there. So plug everything in now. You say, okay, and 50, sample mean 3.3, sample standard deviation's 0.6, and then you say to me things like, but I don't know what mu is. Yes, you do. See the statement over here? Mu is greater than or equal to. What is greater than or equal to? Larger or equal. Mu here is 3. So rewrite this so you can clearly see what everything is. And now you get to use your calculator. Remember, don't forget. You're going to have to put this in the numerator. And then the other division question in the denominator, but you need to put parentheses, right? All right, so we're going to go to the TI. We put parentheses for the numerator. 3.3 minus 3. Close them. Divided by, open a parentheses, put the 0.6, divided by the square root of, what number is there? 50. Move it out. Close it. So double check. That's what we said we'd do by looking at what we wrote down. We just had to include now a pair of parentheses here. So this is how you're using that TI, ladies and gentlemen. So let's hit enter. And you say, okay, I get 3.53555333906. Hey, Mr. Judge, where do I approximate? You always approximate. You always approximate this to whatever the critical value is. Hundredths in this case. So this is going to be 3.5, not 354. You remember that approximation? Okay. The 3 is in the hundredths position. Look at the digit to the right. It's a 5. Means add 1 to 3 gives you a 4. This is my test statistic. 3.54. We now have to see where this lives in our decision rule. And you say, okay, 3.54. In other words, 3.54 is actually positive. So it's to the right of 0. And it's maybe, somewhere over here. This is where my test statistic lives. I'll put an X there. 3.54. Now, what we care about is, where does this live in your decision rule? What region is this? This is in the do not reject the null region. You see, any value to the right of your critical value, any value to the right here is a do not reject the null hypothesis. Any value to the left of the critical value is a reject the null hypothesis. So in this case, since it's to the right of my critical value, we do not reject the null. And what is it not to be to, you have this idea of rejection means you get thrown out, you're rejected. But if you're not rejected, you are kept, you are preserved. They're saying, do not reject this null here. See the null? You don't get rejected. You're not rejected, null. You are accepted. Okay? You accept here the null. Isn't it pretty good to be accepted and not rejected? Yes. So if they say do not reject the null, then don't reject it. You accept it. But the last step is, and I'm going to say this here. I'm going to write this down. Do not reject the null. But more importantly, what does this mean for our conclusion? And this is what you have to write down. Don't be random and arbitrary. Don't sit there and go, I think this. No, this is a legal process, ladies and gentlemen. Legal. Okay? Here's the deal. You did not reject the null. The null happen to be your claim. The null happen to be the claim, and you're not rejecting it. The test statistic is based on the sample. So here's what this means. The sample supports the claim. Well, that's weird. So your sample supports the claim, ladies and gentlemen. And that's your conclusion. Sample supports the claim. Yeah, that's what happens in this case. We didn't reject the null, and the null happens to be the claim. So, yeah. So this suggests that the mean is at least 3. Snodgrass is correct. Students do drink at least 3 cups of coffee the night before a final. Okay. All right, let's give you guys another example of this. This is good stuff. Let's see what Snodgrass says now. Professor Snodgrass claims the mean number of absences are, well, let's see, how about this? The mean number of, what do you guys care about if you are a student? Yeah. Well, the mean number of what? Okay. Absences. Students accumulate is less than 4. Okay, and that would be per semester. So it's all your classes. All right. A sample of 35 college students report a mean of, let's just say 3.8 with a standard deviation of 0.41. Use the 1% level of significance to test this claim. All right. And let me double check something here. I'm going to change this to, not less than. I want to try to do something here. I'll show you guys. Great. Let's say greater than. There's a reason I'm doing this. Okay, you're going to see why. Let's say greater than 4. Now, when you go through this question here and you say, okay, what do I do? Well, you go through, you read it, and you notice these phrases, right? You notice that Snodgrass is making a claim, and then you read it all the way through, and they say use the 1% level of significance to test this claim. You go, oh, that's a hypothesis testing question. All right. What's the claim, though? Since it's a hypothesis, that's the same thing. The mean number of absences, so the parameter here is mu for mean. The mean number of absences students accumulate is, and then you read this phrase, greater than 4. Greater than 4, ladies and gentlemen. So when I write this down, I'm saying, oh, mu greater than 4, that's the symbol. It's the greater than symbol. This is the claim. You go, okay, that's what Snodgrass is saying. Okay. We set up the hypothesis. So you say, when I start to set this up, I have to know, did Snodgrass make an alternate hypothesis? Did Snodgrass make a null hypothesis? What kind of hypothesis claim did Snodgrass make? What do we know? You know what, Snodgrass? This mu is greater than 4. That's an alternate hypothesis because it lacks a condition of equality. And I always put the claim right next to it because I got to know what's going on here at the very end with the conclusion. So you want to start with this exact process, ladies and gentlemen. You don't want to switch the process or be intermittent with the process. So, write down what the claim is and where it belongs. It's either going to be a null hypothesis or an alternate hypothesis. Don't always think it's a null because the first two examples were a null. It could be an alternate. Okay? So you have to put it in the appropriate position. And then you have to write the logical opposite. And you say, well, logical opposite, yeah. The null hypothesis is going to be the opposite of greater than is less than or equal. Don't think it's just less than. The opposite of greater than is not only less than, it also is less than or equal to. It could be equal. So these are logical opposites. So at this point, when you look to create your decision rule, all right, let's try this again. I'm going to remind you guys that you always, right? Did I say always? Yes. Always look at the alternate hypothesis to see the direction of that arrow. That's pointing to the right. So this is why, ladies and gentlemen, I wanted to change this on you so I can give you an example of a right tail. So this is a right tail test, also known as a one tail test. In the middle, we have a do not reject the null. The shaded region is a reject the null region. You guys need a critical value here in our decision rule. So yeah, always look at the alternate hypothesis. In this case, it's greater than, it's pointing to the right. That's a right tail. If it's less than, it's a left tail. If it's not equal, it's a two tail. Always, always, always. So these are the three types of tests you guys can see here. Now, if you go back and you say, well, how do I start finding that critical value? You need to know this important piece of information. 1% level of significance. That means alpha is 1%. So I'm going to write that down. Alpha is 1%. And that's my level of significance. That means 1% is in that tail there. And that implies we got 49% here. This is what we're going to look for on our Z table, 49%. All right, and if we find 49% on that Z table, we're going to actually be able to find the critical value. So we go back to Word, and we're going to get rid of this here. Now, 49% is 4900. Get rid of these things here. 49%, ladies and gentlemen, if I can. Oh, good. We got to look for 49%. And so we look for 49%. And I don't find 49%. The best I find, if you can see it there, ladies and gentlemen, the best we can do is right in here. 49.01. That's like 1 penny over. $49, that's $49.01. Now the next closest value is 48.98. That's 2 cents short. So, I can add one. I can add the values and divide by 2. Would I get a little closer? Maybe slightly. I'm going with 49.01 though. That's okay. So 49.01 is in row 2.3, column here, the 03 column. 49.01, don't forget, row 2.3, column 03. 2.33 altogether. 2.33. All right, now. This is my critical value. And then remember, I'm going to go through this again. We're going to compute a test statistic. Any number bigger than this, any number bigger than 2.33, we reject the null. Any number, ladies and gentlemen, for a test statistic value that's smaller than 2.33, we do not reject the null. This is how we read this. We just have to know what that test statistic value is. Now, remember what I said. The test statistic, ladies and gentlemen, is the sample mean minus the true mean over standard deviation divided by the sample size. Always write that down. And I said, okay, let me put it to the right here. You just have to remember what's your sample information, right? They're going to give you n. They're going to give you the mean. And they're going to give you the standard deviation. So we need this information. So you have to go back and read this and say, okay, what does that say here? It says a sample, of 35. Well, that's simple. That's n. College students report a mean of 3.8. Oh, X bar. With a standard deviation of 0.41. Oh, it's my standard deviation. So we're going to put this stuff down here. N is 35. The sample mean is 3.8. Sample standard deviation is 0.41. So we're going to plug those values in. So you say, oh, this is 3.8. S here is 0.41. Sample size is 35. We need to know what mu is. Go up here and find mu. This is where mu is here, ladies and gentlemen. Mu is less than or equal to 4. That's where your mu will be. So that means mu has a value of 4 because it's less than or equal to. So here's your 4. And like I said, I always write that down so that I can very clearly enter what I need in my TI calculator. So we're going to do that now. So remember, when we enter in the TI here, you got a difference in the numerator. We got to put parentheses there. And we got a quotient in the denominator. Don't forget, we're putting parentheses here. And that's what we enter in the TI. So we say, okay, TI, parentheses, 3.8 minus 4 divided by 0.41 divided by second square root 35. Now, get out from under the radical. with this arrow key and close your parentheses. So this is what we do, and double check, ladies and gentlemen, I did it the way we wrote it down. All right, we did it the way we wrote it down. So, all right, TI. Hit enter and approximate this to the same place value of your test statistic, because we're going to see where this lives in the decision rule. And that's negative 2.8. Now, the critical value is to the nearest hundredths. So the second 8 we changed to a 9 because the third digit was a 5. So my test statistic is going to be negative 2.89. Here's your test statistic value. Negative 2.89. Now we say, where does this live in our decision rule? Right? All right, where does that live in our decision rule here? So we have a question here. Why is 4 and not 5? I'm assuming you're talking about mu, Joanna. And mu here, right here, mu is 4. Okay, so here's less than or equal. Mu is less than 4, or mu is equal to 4. This is why you say 4 for mu. This is why we use that. Now, we have to see, where does negative 2.89 live on your decision rule? Well, it's to the left of 0, because every number to the left of 0 is negative. So it could be somewhere over here. I don't really care where it is exactly. I just really care about what region this is in. This is where that test statistic is. It's in the do not reject the null region. So I'm going to write this down here. It's not my conclusion. Do not reject the null. I'm going to put a lowercase. Do not reject the null. So if you do not reject the null, right, you're not rejecting. You say, where's the null? Here you are, null. We don't reject you. We accept you. Null, you're not rejected. Right? This is it. We not reject the null. Don't reject it. If you're not rejecting it, you're accepting it. That's what this test reveals. However, let's see if you guys are really awake on this one. What is the conclusion? And there's only really 2 possible answers, ladies and gentlemen. So I'm going to ask you to look at this piece of information here all together, and I want you to tell me what your formal conclusion is based on what we talked about today. What's your formal conclusion? Because on a test, I'm going to ask you these kinds of things, right? Let me be specific here. Let me go back to, let's try to go back to the browser, I guess. Browser. You go to the browser here, and we're going to look for this statement here. We're going to look for 227. We're going to look for test bank and 227. Let's find it. Right. 227. Let me just pick one here. Oh, it's not 227. That's 125. Okay, where are you at? 227. There you go. Let's look for a test 4. Maybe there's something here. Here's a pretty good test. And here, notice the details of what I'm going to ask you. Look at this question here. Actually, going to look at this. You can look at the next question. Yeah. I'm going to read it to you guys. An online researcher claims that the college students spend a mean of at least 6 hours per day on the internet. A sample of 250 college students report a mean of 4.8 hours with a standard deviation of 2.6. And notice what they ask you. The first question is, what is the claim? So these are the kind of questions I'm going to ask you. Can you read this and tell me the claim? Second question, what are the critical values using the 10% level of significance? And I even put down where you approximate hundredths here. So if you guys can see that, this is where we're at here. Maybe I should make that large. There we go. All right, let's scroll down. Larger. Scroll down. Here's what I'm reading. Question 16, I'm going to ask you, what's the claim? Question 17, I'm going to ask you, what are the critical values using the 10% level of significance? Number 18, what is your test statistic value? You have to compute it. So this is the kind of questions I'm asking. And number 19, we're going to say, what is your decision? Now, what happens here is you always know somebody who didn't do their homework like they should. They put all kinds. They put a paragraph for you to read. I'm not interested in your creative writing. This isn't that course of creative writing, ladies and gentlemen. Science isn't creative, at least not in that way. When you have to report a decision, you can't be creative. Save that for, the philosophers and the law students and blah, 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 right? So they want to know what your decision is. And this is the kind of questions I ask over and over again for every hypothesis testing question. Do you even know the claim? Can you find the critical values? Can you compute a test statistic? Do you know what the decision is? It's really testing you on the process. And yes, again, you guys remember, you want to turn in your work. Okay, you got to show your work. Some people don't do that, and it's like pulling teeth. They refuse. I'm not showing you any work, and they run and they hide and they don't show you anything. And I'm not. You're getting a 0 then. If I can't see your work, you guys know what I mean? Got to show this work, and I'm going to put that on the test. Anyway, we need a decision. Now let's see. Let's go to the iPad and let's write down our decision for this situation. Let's see who knows this. Here's what I'm going to say. I'm looking at it. Well, let me look at it. Do not reject the null. Here's what you write down. The sample blank the claim. The sample, ladies and gentlemen. Oh, notice what we accepted. We accepted that mu is less than or equal to 4. That is not what we accept, is not the claim. Oh, no. This means the sample does not support the claim. Here's the conclusion, the formal conclusion that we're looking for. Sometimes people write this as their conclusion. They say, do not reject the null. That's not your conclusion, ladies and gentlemen. You can't, your process in science is thrown out the window because it's incomplete. So if you do that, I throw it out the window too, because this is a college level course. And you're expected to write down that proper conclusion, right? So let's see. Let's double check here. What are we getting here? What are some comments? Let's see. Does it change the fact that the claim is in the alternative? Nope, that has nothing to do with it, Anthony. It doesn't matter where you put the claim. This process is independent of where the claim is at. So nope. The sample supports the claim. No, it doesn't. So let's see. Let's go back here. Oh, Joanna. The sample supports the claim. No. So nope and nope. Let's go back. Maybe I'm wrong. What did we do? Do not reject the null right in here. So here's the null. We didn't reject it. We're accepting it. Guess what? The claim, ladies and gentlemen, is down here. The claim is the alternate. The sample is saying that the mean is less than or equal to 4. That's what the sample is suggesting. The mean is less than or equal to 4. The claim is that the mean was greater than 4. That's why I wrote it down that way. So what's happening with this sample is it's not supporting what was being claimed. So the mean is less than or equal to 4 based on the evidence that the sample provides. And that is not the claim. Okay, the evidence is indicating that the mean here is greater than or equal to 4, which is not your claim. So the evidence is suggesting that, yeah, your claim is wrong. But what do you say? How do you say it? You say it this way. The sample does not support the claim. And that's a does not support situation. All right. So yes, I'm glad you guys are going through this. Now remember, how you learn is by making mistakes. You don't want to learn or make mistakes the night before a final. I mean, because even if you make mistakes, that doesn't mean you're learning there. So you don't want to go, oh, there's a mistake the night before a final, and then your blood pressure is through the roof, and you're panicking, and you're going, oh my God, and I don't know what to do, and you're running around a circle in the living room, right? You want to make your mistakes now. And what that means is you also want to work on homework now. You want to do the work now. You don't want to wait till later and, yeah, I got enough time, and all right, no, you don't have enough time. Okay? So we got some more questions here, and good questions for a test. Yeah, Matthew, this is why I keep some of those things up, so people can actually understand. Yeah. Oh, I guess, Mr. Judge, you do ask these kind of questions. Oh, I didn't know. Oh, interesting. Yep. Sometimes that's good information. Let's see. Cassandra, yes, it's not tricky. It means you got to think about what's really happening. The phrases are in relation to the null. First of all, a lot of times students think that every hypothesis has to be a null. No, how you think and what you say can be an alternate type of hypothesis. So that's not happening. So you do have to go through the process, and you have to finish it the way we did, and then go back and think about, you wrote down what the claim was, what you're accepting, and what you're rejecting. So anyway, I'm going to say to you guys have some homework here. I actually started here on section, I start with a mean, and the book starts with a proportion. So I'm going to say to you for homework here, let's go to the web. Let's go to the browser. You guys want to make sure that you go here to Statistics Lecture 14. If you see Statistics Lecture 14, ladies and gentlemen, on the web, that's when you're going to start your web work there. The book, however, this is actually 8.3. I start with hypothesis testing about a mean. The book starts with a proportion. It waits to 8.3 to get there. So for book work, I'm going to start with we're going to start with 13 to 23 all. All right, let's go back to where we need to go. Let's go back to the iPad Pro. So, all right, here's the iPad. This is the homework you guys want to start here with hypothesis testing. Now, we just started it, which means there's going to be some questions you may not be able to do. This is just a start for what we're doing. And yeah, it's a bit tricky, and you definitely have to go through this. So take a look at some of those. Now, if you said to me, boy, Mr. Judge, I think I want to go look at some more examples for this, well, you go to the browser, and you guys already know, and let's kind of do that here. If I do this, put it lower. It's kind of weird. Here's Statistics Lecture 14 again. We have some math videos. Person works for the news, by the way. Channel 34 in Las Vegas. Here's the lecture. I go through hypothesis testing. I go through some examples. 75 are. So you do have additional examples there for yourself, and I'm going to say take a look at it. The final and the next test will show up a lot faster than you realize. You think you have all this time. You don't. I'd say get some of this done ASAP. Started now. And we're going to continue with hypothesis testing. We're going to start 8.1, which we're going to do hypothesis testing about a proportion next. So anyway, I hope you guys stay safe and have a great weekend. Look over these things and have a good weekend, a good productive weekend. Don't procrastinate. There is no tomorrow. Look at it that way. And I want you guys to take care. All right? Have a great weekend, and I'll see you guys on Monday. I have office hours. I'll send you a notice on that, and hopefully you guys will be there. All right? If you have any questions, take care or email me. All right. Goodbye.